Let's start today's session by taking the queries that have been asked. So, first, we will start with the queries that have been asked on the Google form, and then we can take up your live queries through comments. Okay, so let me just begin. Yeah, so this first query has been asked by Engineer Devlin. He is joining us from Oman. He is a working professional, and he is saying, in PEB, which of the following is a correct approach? Assigning truss member specification to bracing and struts, or assigning tension member specification? Okay, so let me just open. Uh, just a minute, I'm just opening the OneNote so that we can write over there. Yeah, so I think now you can see the OneNote file, and he's saying which is a correct approach. So if I were to just share a screenshot of a sample model, let's take up a PV model. Yeah. So assigning trust member specification. So he's talking about these bracings. I think all of you can see them on the screen. So he's talking about these bracings. So whether to give truss member specification or tension member specification. So see, when you give truss member specification, what will happen? That under all the load combinations, it will be treated as tension only member. Okay, under all the load combinations, no, sorry, under all load combinations, it will only be analyzed for moment. It will only be analyzed for axial forces. It will not be analyzed for any moments. So that is what happens when you assign a truss member specification instead. So either there will be axial compression or axial tension. There will be no rotational rigidity provided by this member. So it will only be taking axial forces, and that's how it will design. But you must understand that what we want actually is that our bracings in PEB design generally strategy is that we keep a very high L by R for bracing members, so that they are only effective in tension, effective only under tension, and under compression we will assume that they will buckle and they will not be able to uh, provide any resistance to compression. So that is our design assumption. That is how we provide bracings in these types of industrial sheds, or for that matter bracings in general in steel structures. We usually provide them assuming that they are effective only under tension. So so giving truss member is not correct. You should give it as tension member specification. So under tension member specification, what will happen, that this will be member will be effective when you apply this specification instead. It will be effective only when there is a tension force, and let's say after analysis, if the member force is compressive in nature, then that particular bracing will be considered as ineffective by the software. So that is what software will be able to do on its own. So you should give tension member specification, not truss member specification. And should you release the moments? I would say no, don't release the moments unless you are able to develop a perfectly pin connection. So if you are able to develop, or if you are able to, or if you are going to provide a perfectly pin connection, that means an actual pin connection, then only release the movements. Otherwise, do not release the movements. Anyway, because of the configuration and geometry, you will not see very heavy or very high magnitude of movements in the bracings. So don't be very worried about the movements as such. So uh, do not release the movements. Okay. So just to summarize, assign them as tension member specification and do not release the movements. Also, because you are assigning it as tension member specification, be careful that you will have to also use the change command. Okay, so that is the stat syntax where you will have, you need to use the change command after each load case. All right. So that was Mr. Devlin. Then we have Mr. Dinesh. He is a working professional. And what are his queries? Let's see. So I'll just paste it. These queries are from Engineer Dinesh. So he's saying, is there any limit on lateral deflection of steel beam as per IS 800 in plan direction? So I think what he's trying to ask, in plan view, let's say this is my column. I'm just trying to draw plan view, column, column, and these are steel beams in plan. Green is the beam. So what is the question? Is there any limit for lateral deflection? So I'm not sure what type of lateral deflection it means. See, there can be one lateral deflection in a way where the entire frame is swaying laterally. So your beam reaches this point in plan, column reaches this point. So you could say that the entire frame has swayed laterally by this amount. So is he asking about this lateral deflection? Or there can be another possibility where the beam is undergoing a deflection like this in plan view. So in plan view, if your beam deflects like this, that can be another form of lateral deflection. So I'm not sure which lateral deflection he's asking, but if it was the first type of lateral deflection that he's asking, so there is no such direct limit on uh, lateral deflection of beam, because it is going to be controlled by the sway deflection limits for the frame. So if your sway deflection limits are controlled, naturally this deflection will also be under control. The second type of deflection, which can be a possibility, will be the deflection like this. So a deflection like this in plan view for the beam. But this type of deflection, if you ask me, it's very rare to observe this type of a deflection, because there is no real reason why such a deflection should come, unless there are some loads acting like this on the beam about its minor axis. Then only this type of deflection is possible, not otherwise. So I don't see a realistic scenario under which this type of lateral deflection will occur in the beam. But if at all such a deflection is happening, is there any limit? So I have not come across any such limit. So maybe if there is no limit given in IS 800, you will need to rely on your own experience, and you will need to manage these deflection values so that it is not detrimental to your structure. Okay. Okay. So this was another question. Then we have, so this was engineer Dinesh asking. He was joining us from India. He is a working professional. Then we have another question from Sriram Rao. He is joining us from Chikmagalur, Karnataka. He is an independent consultant. and he is asking that. So it's not a question; it's sort of a comment. So his question or query or comment is it possible to develop a course for consultants based on their inquiry? Example, if I want to learn only PEB shed design with an example without much theory. So for these types of course, I mean, with this vision, we have the project design courses where we just take up a particular project and do that project as if it is being done in a consultancy office. So we have these courses. So perhaps you could have a look at them. But yeah, sometimes it becomes difficult to just uh, discuss only projects because then some background knowledge is required, and if that background knowledge is missing with the participants, it becomes difficult to then conduct a course where we are just doing a project as it is done in design offices. So we have to give some background theoretical basis also. So yeah, we do have these project design courses, but then in those courses also we have to give some theoretical background, or we have to uh, discuss some theory part also in order to enable the participants to then do the project design. Okay. Yes. Next question is from engineer Harshal Kadu. He is joining us from Navi Mumbai. He is a postgraduate student and he had shared a model. His doubt was that in a model he was finding the structural reactions for earthquake loading in a PV shed to be of a low magnitude, and actually this he had shared this model. He had also shared the same model. So he was saying that for this, that suppose, let me just put some axis. So let's say this is the x-axis instead, this is the z-axis, gravity is the y-axis. So for EQ in z, he was finding this is an industrial shed type of structure. So for EQ in z, he was finding the support reactions to be quite low. So his question was why such a thing is happening. So see, in these types of industrial sheds where the seismic weight is quite low, there is no real reason why you should get very heavy earthquake forces. So you can just check the total base shear. Stat gives you the total base shear value. Just confirm or cross verify whether that base shear value is coming as per this or not, and you will see that the magnitude of base shear is quite low, and because base shear magnitude is quite low, you will see the reactions also not very high in case of these types of industrial shed like structures, especially for earthquake loads. So these types of structures are more critical for wind loads. They are more wind governed rather than being earthquake governed. Okay. Yes. Next question is from engineer Mansimran Singh. He is joining us from Ludhiana, and he's an independent consultant. So what he is asking, let me just copy. So Mr. Mansimran Singh is asking, let me just increase the font size. Flange beams should be modeled or only rectangular beams in ETABS? I have heard some consultants say design assuming a rectangular section but analyze using flange sections. So I guess he's asking whether we should analyze our beam like a rectangular, sorry, like a T section or an L section. So see, analysis part, let's say if you are doing it in ETABS and you have modeled the slab as shell elements and you have modeled the beam as line elements, so automatically what is going to happen, there is going to be interaction between the shell and the line elements. So automatically that in the analysis you will get that effect of flange section. So you don't have to do anything else, but because you have modeled the slab, and because you have modeled the beam, and because you have modeled the slab as shell elements, uh, that thing is covered. Now, should you design your section as a rectangular section, or a T L section, or a T section, or a flange section, so to say? So the answer is that because at the hogging, in the hogging moment zone, because in the hogging moment zone, what will happen? That tension will be at the top and compression is at the bottom. So when tension is at the top, anyway, you have to take only the reinforcement. So at that time, this rectangular, sorry, this flange section is not helping, because in hogging moment, anyway, the reinforcement has to be considered. Okay, so it does not matter whether your section is rectangular or a flange section, because in hogging, under the effect of hogging moment, it is going to be this reinforcement only. Now, when will this flange section be of advantage? When you are checking it for sagging moments, let's say. Then what will happen? That this entire thing is under compression. So you will see that the compression block has a larger area. So under the effect of sagging movements, this flange sections provide us benefit in reducing the AST required. But if your beam design is being governed by hogging moments, it will not be of any use. Understood? So, and because in most of the continuous beams, you will notice this, that the design is governed by hogging moments. So usually we will design our section as rectangular sections only. Clear? So short answer, analysis part, you need not do anything if you have modeled slabs in ETABS and uh, line elements for beams. Software is able to consider the shell line element interaction on its own. Analysis, you need not do anything. And for design, I just explained that in the hogging zone, uh, flange sections do not provide any advantage. In the sagging zone, they do provide advantage, but because beam design is governed by, generally the continuous beam design is governed by hogging moments, so we don't get that advantage of flange sections. So therefore, as designers, we most of the times ignore the flange section. Okay. Next question is, in effective length calculation of RCC column, we take shallower depth out of beams and slabs at the column junction. Shall we check the beam or slab for adequacy of providing lateral restraint? Yes, very good. So you should check whether or not your slab or beam is able to provide a credible lateral restraint. But the general thumb rule is that it should be able to take 2.5% of axial force in the column as compression load. So for any member to act as an effective lateral support, it should be able to take 2.5% of axial force in that particular member to which it is providing a lateral restraint. So it should be able to take 2.5% of that axial force under compression. It should be effective. So usually now, if you see in columns, the PU is not very high, and 2.5% of that will be even a lesser value. And if you have in plan view, if I show you, this is column, this is beam, and imagine whatever is the axial load, this beam has to take 2.5% of that as compression. So it will be more than sufficient to take that axial load. So generally for RCC, we are not very worried whether a particular secondary member will be able to provide a effective lateral restraint or not. But yes, in steel structures, because those sections are slender, uh, because we are using thin sections, we do check this adequacy. In RCC, we don't check because we are almost certain that this check will be satisfied. Okay. All right. So these were the questions asked on the Google form. Now let us take questions that have been asked on the live YouTube comments. So Akash Babar has put a series of questions. Let's take them one by one. So his first query is if 28 days strength of M30 concrete is less than code specified and the columns are already cast at site, then what is the solution? So see, first you need to find out that how much less is that value. Okay, how much less. So suppose your FCK was 30 and 28 days strength is coming out to be, let's say, 25. So I would say that is not so bad. That is not so bad. Okay, but let's say your value came out to be 9 or 10, then that is a problem. 25 Newton per mm square, let's say 28 days strength, even though it was not reaching 30, but you know that over, let's say, next 1.5 months, that strength is going to increase. All right. And you also know that your structure is not going to be loaded to its full load levels. Maybe for the next 1 month, it's not going to be loaded. Or maybe for the next 6 months, because it is under construction, it is not going to be loaded with uh, those load levels. So if you know those sort of, if you have that knowledge of condition under which your structure is, or what is going to be the load future in future, what sort of load is going to come, then you can take a informed decision. So let's say if your 28 days strength was pretty low, instead of 30 it drastically was only 10 newtons per mm square. So you know that even after 1 year, 2 years, that it is not going to acquire or gain that level of strength. So in this type of scenario, you may have no choice but to strengthen your columns or just dismantle them and cast them again. But if it's a marginal thing, maybe you can take an informed decision that okay, uh, I still have time of 6 7 months because further stories are going to be constructed, and maybe after 7 months, 1 year, uh, maybe after 7 months, 1 year, this stress level will be reached. So then you can take that informed decision. Mr. Akash Babar is saying refer table 11 of 456. Concrete is not satisfying this compliance. What was the compliance? Just a minute, let me just open code. Which table are you saying? Table 11. Table 11. Table 11. Table 6, 7. Where is table 11? Characteristic compressive strength requirement. Yeah, that's fine. I got the point that it is not satisfying the codal requirement, but then we cannot just break that concrete, isn't it? There is cost involved. So we are just trying to see a engineering decision what to do. Okay. So depending on how bad the values are, you need to decide. So three options: whether to wait for concrete to achieve more strength, or whether to dismantle the concrete, or whether to go for some strengthening measures. All right. Okay. The next question is: should piles socketed in rock need to be designed as column, or just nominal reinforcement sufficient? End bearing. Now, so that will depend on the amount of axial load your pile is having. Even though it is end bearing, still we would like to at least design it for some minimum eccentric uh, movements. That means based on minimum eccentricity, you can just multiply the axial force into that minimum eccentricity and design for those movements. If there are lateral loads, then you need to find out the uh, moment under the effect of those lateral loads in the pile. So it will depend on the type of reactions the pile is subjected to. Then Mr. Akash Babar is saying, should PCC be provided below strap beam, or else should soil below strap beam be loosened? No, by strap beam you mean joining two footings? Yeah, so if it is joining two footings, and if the bottom of those two footings and strap beam is same, PCC should be provided, just because you are going to. So for example, in section view, this was my one footing, this was another footing, and this was my strap beam. So now, because this strap beam bottom and footing bottom is common, it is better to have PCC over here also, because when you are going to cast this strap beam, you want to retain the slurry properly. Cement slurry and water should not flow into the ground. So it is better to provide PCC. Okay. Yeah. Then Mr. Akash Babar is asking, what if LD plus 10D anchorage length not provided at site? What site adjustment needs to be done? So then in that case, you can provide some lap extra bars. For example, in sectional view, I'm showing that this is my column, this is beam, this is cross section, and let us say you had provided a beam reinforcement, and maybe it was something like this. So this development length, this is not, or this is less than this. So now what to do? So now you may have to lap, let's say, another bar, and if you don't have space to take it down, maybe you can take it up, and then ensure that first of all this lapping should be at least LD, and then beyond this, from here to here, give something like this. Okay. Or maybe if it is possible, although it's very difficult to execute it on site, you can think of doing something like this also, but it will be not possible to develop this like this. Or if you have enough space, maybe you can add another bar and take it below like this. But for that, the dimensions you will need to check first. Okay. So lapping with another bar, and then ensuring that LD plus 10.5 is provided, can be one of the adjustment that you can do on site. So in my personal opinion, if it's zone 4, zone 5, or seismic zone, only then do such things. Otherwise, I would not say for zone 2, zone 3, this much is required. Okay. All right. So yeah, these were his questions. So I think we have answered all the queries in the Google form, and we have also answered all the queries in the comments. So is there anything else? Any further question? Hello. Any further question, please? Okay, so Mr. Akash Bawar is asking, since column grades are higher than slab beam grades, then junction is cast using lower grade. No, no. So junction, no. So generally what we do in such cases, that you will use a stopper like arrangement. For example, if I were to show you, this is my sectional view again, I'm showing this is my column, This is my beam. This is column. So let's say beam you are casting in M25 and column you are casting in M50, suppose. So now his question is that what usually happens as per construction sequence, that you will cast this column till beam bottom, and then when the beam is going to be cast, it will be cast in M25. So now what will happen, that this junction is M25, and then next concrete again will be cast in M50. So what you will see is that this beam column joint, which was a crucial intersection, it has been cast in lower grade. So we don't do it like this. Generally in these situations, we will cast. So we will have some shuttering stopper type of arrangement made on site, where what we do is that you will put a stopper over here, okay, or not even over here, some, yeah, some over here, let's say, or some people also may extend it slightly ahead, if that is possible. Although that this providing this plank over here, shuttering plank, may not be possible because you don't have the bottom ready while you have casted the column. So this may not be possible, but at least you can have a plank stopper like arrangement made over here. Then you cast your concrete till here, okay, this stopper is in place. Then you cast your beam till here, okay, so stopper is still in place. And then in the next go, you will cast your fresh concrete once again, column concrete. So then you will find that even the beam column joint and the columns are cast in higher grade, okay. So this is what we do. Yeah, I hope that is clear. Okay, so using a stopper like arrangement to ensure that the beam column joint does not get cast in the grade of beam is done on site, okay. All right, what else? All right, so I think those are the questions we had for this week, and we have answered all the queries in the Google form, also on the comments. So that's it for this week then. Thank you, and now we'll see you next week, okay. So till then, thank you and bye bye.